A comparative study on ciphertext policy attribute-based encryption schemes. Abstract cloud computing is one of the demanding services in the current times. It should be said that it has become a necessity of small to large-scale business to have a dedicated cloud computing service. The security, privacy, and other features must be kept intact in all conditions. This high demand has made cloud computing being utilized in several ways, such as in Fog VANETs, mobile cloud computing, and many others. All these are based on a common encryption scheme known as CP ABE, Ciphertext Policy Attribute-Based Encryption Scheme. It is an enhanced form of ABE which allows owner to set the attribute of user within the encryption. As a result, even after sharing, the data stays secure, and this is one of the reasons which compelled many to use this as a base for their targeted encryption scheme. This is quite flexible to be utilized in a vehicle, mobile, and in fog systems which are based off of cloud computing. In this review paper, our contribution lies within the range of qualitative analysis of ABEs and CP ABEs. The comparison will be shown in tabular form on the basis on the criteria of an ideal encryption scheme. This could be helpful for selection of a suitable scheme for a specific type of tasks in cloud computing. Keywords: cloud computing, PAB, ABE, VANETs, fog. Security, privacy, access control, encryption, decryption. Introduction. The requirement of keeping the flow of data continuous and available on demand to the user gave rise to the cloud services. 2. The most appropriate technology for such is cloud computing, since its nature makes it scalable and flexible for implementation of above requirements. It allows users to share data with authorized users, but with its quality nature there lies its weakness as well. Cloud computing is quite insecure without any proper infrastructure, because once a user shares their data they loses any control over it. Any unauthorized user may probably decipher it and collect the information for themselves. This makes the system based on such insecure techniques to be more susceptible to attacks from hackers. In 2005 an encryption scheme was introduced by Singh and Waters known as ABE, Attribute-Based Encryption Scheme. The objective was to eloquent execution of cloud computing with fine security and access control. In this scheme the ciphertext and key depend upon a certain set of attributes to identify the authorized user and correctly decrypting the data. A year later another scheme was brought into existence. It was known as CP ABE, Key Policy Attribute-Based Encryption. This embedded access policy within the user's attribute to provide a better control to the user. It also had a flaw in the system which didn't allow the users to select who can decrypt the data. The user was allowed to just set the attribute that can describe the data. It was better than ABE but still lacking in a way that compromises the entire aspect of access control. In 2007 a scheme was put in action that allowed users to attach a tag to each attribute. This was ABE with a non-monotonic access structure, the contribution of Ostrovsky. In the same year another scheme named CP ABE, Ciphertext Policy Attribute-Based Encryption, Bethencourt et al. This scheme allowed the user to set attributes which describes user's credentials, and the users encrypting the data establishes who can decrypt. This solved the problem of CP ABE but still had some weaknesses of its own. The review will be focusing on how the scheme CP ABE is being modified in order to cover those gaps and also investigate on this scheme's selection over other schemes in the first place. The most defining features of an encryption scheme. A. Security. The ideal security must have protection against all types of currently being used attacks. The most recent example would be ransomware attacks that locks away a user's data and demands payment to be unlocked. So the information of the user must be kept safe in every situations. For that, few measures are as follow. Top-tier firewall protection. Improved intrusion detection system. Applications and database equipped with dedicated firewall protection. Storage of encrypted data in cloud infrastructure. Installment of top-level physical security to data centers. Avoidance of data loss from client's database. Making system data leakage proof. Allowing the complete control to disclosing the data to the user. B. Privacy. It is most simple yet essential feature in cloud computing which correlates with both the security and access control. The privacy still is a standalone features that need attention. The best privacy would be C. Access control emergency lockdown features. Ease of establishing and maintain access control group. Instant configuration of current access rights. Ability of integration with currently popular softwares. The access control determines the user's access to the data set by the data owner. The high-profile data accessed by an unauthorized user can cause serious problem for the client. So the data must be protected from unauthorized users, and you need more than just username and password authentication. 2 qualifying aspects to be an ideal attribute-based encryption scheme. 7-13 A standard system was necessary for a suitable scheme to be selected for cloud computing, which gave us the list of aspects which we will be used to evaluate the quality of the encryption schemes. A. User accountability. This is a case of an improper conduct committed by an authorized user when they share their private key with an unauthorized user. Here the misconduct must be dealt with, and handling of such issues should be included within the system. B. User revocation, identifying the currently inactive user. Revoking the rights of users according to owner. Maintaining an honest cloud service. The revoking of the rights of an user who has exited the system. This plays a major role in ensuring the security of other users who shares the same space. C. Scalability. This is one of those key features which was used to promote the cloud computing services at its dawn. This describes the flexibility of the system to provide the owner the type of service that they require as they demanded in the first place. The change in the services and resources utilized for owner according to their demands almost instantly. This aspect still makes the cloud computing services all the more desirable to customers. D. Data confidentiality. This aspect only allows the authorized user to access the data, since it has been encrypted to keep the data hidden from access made by the unauthorized user. The encryption of data ensures the safety of stored data from any unauthorized actions. This is one of the strict rules that the cloud service must follow themselves too. E. Collusion resistant. The resistance towards an attack that is executed by having multiple attributes to combine and form a key that can decrypt a ciphertext associated with the targeted user. This is an attack which can be carried out by a group of unauthorized users or a malicious attacker in possession of multiple attributes that were acquired through hacking a user or by their assistance. F. Fine-grained access control. This also considered one of the defining aspects of the cloud computing services. The ability to maintain the access rights to the data, assigning a new access control for a new user, and basically having complete control of the data's revelation and also to whom it may be shown. 3. Literature survey. The literature survey contains all the information regarding the encryption schemes such as ABEs different types. It will also include all the different CP ABE schemes that were reviewed. This will contain all the crucial information on the schemes, their advantages and disadvantages based on the above shown aspects. ABE, attribute-based encryption schemes. 8. The primary goal while constructing this scheme was to provide better security and access control. Since naturally cloud computing in its naked form is completely unsafe to establish a service. The entities within the system are sender, data owner, receiver, data user, and authority generates key for data, both the entity to use for the encryption and decryption. Lack of a practical attribute access to be applied in real situations. It is heavily dependent upon key generation. It is very taxing while dealing with large number of authorized users, since requirement for encryption are their public keys. An access policy will be created according to the data, which will act as the condition required to decrypt it. The implementation of receiver's attribute within the encryption allows only the authorized user with that specified attributes to decrypt the ciphertext. Disadvantages. CP ABE, Key Policy Attribute-Based Encryption Scheme. 9. This scheme is a type of ABE. All the ciphertexts are created with access policy instead of user's attributes. It is completely reverse form the another type of ABE. In this scheme, decryption is performed through user's attributes. An access structure is assigned to every private keys, which only allows specific ciphertext to be decrypted by a particular key. This scheme very loosely allows the exertion of control over ciphertext decryption. Since the data owner must stay reliant on the work of key allocator, the tree structure does not allow the multiple parties to perform cooperatively. The process starts from generation of public parameters pk and master key mk, then selection of a random value from set of attributes provides us with our ciphertext, hence completion of encryption. A key is generated which authorize encryption only and only if the attribute of the user matches the access policy. Disadvantages. CP ABE, ciphertext policy attribute-based encryption schemes. 6. This is another modified version of ABE. This includes the creation of an access policy with user's attributes for encryption and only allows a user decrypt if their attribute satisfies the condition of the access policy. It is exact opposite of CP ABE in terms of selection of parameters for encryption and decryption. It starts with generation of public parameters pk and master key mk from the setup algorithm. A ciphertext CT is produced employing an access policy to encrypt the message taking the public parameters pk as an input. Key generation takes the mk master key and a set of attributes s that describes the key and provide with the secret key sk. It has low resistance to collusion attacks. The scheme is very rigid and does not perform well with exceptions or customization. Disadvantage. The one and only demerits appears in the base MABE is that each authority's set of attributes must be disjoint. The comparison is done between the original ABEs and its types using the aspects of an ideal encryption schemes and performance. Here the table 1.68-10 shows the scheme's capability to support the qualifying features. EHABE, Hierarchical Attribute-Based Encryption Scheme. 11. It is derived from the HIBE and contains very similar properties. It includes hierarchy of domain authorities and various attributes are provided to the user. All the secret key SK assigned to the users will be a leaf of the SK of root domain authority. The attribute is excluded from abiding by this hierarchy rule. This overall structure does follow the hierarchical format where the leaf domain authority does not have clearance to decrypt the ciphertext related to its root and entities above them. The main parent authority is capable of decrypting all ciphertext. It is one of the major concerns because if it get compromised, entire scheme will be compromised. Conclusion. The selection of the CP ABE for further research and development of an original scheme for specified purpose or service is justified according to TABLE1. It does has its shortcomings such as the poorly present collusion resistance and absence of scalability, but it still produce consistent performance. This is also further proved by the table 2. That these factors calls for the requirement to enhance its core features as well as overcoming other weaknesses. If such enhancement are successful, then it will be a balanced base to be adopted and customized to build any type of cloud computing service.